All right, so what I want to do with this next short video is we need to tackle the issue that you might have on the AP test where you are going to be having to approximate a pH based on hydrogen ion concentration without a calculator. So if you already looked at the key, you might have already seen this, but I want to go over it just to make sure because it's going to come up again when you're approximating the ranges of your pKa's. You might get a table of the pKa or something or a range, and you've got to be able to make that conversion kind of using some mental math. So basically I have this concentration. Now if you remember back in pre-AP and academic chemistry that if I have a hydrogen ion concentration, let me get a different pen here, this one's not working very well, of this, my pH will be 4. It will correspond, if there is a 1 in front of this, if your coefficient is 1 only, then my pH corresponds to the coefficient. So if my hydrogen ion concentration is 1.0 times 10 to the minus 9, my pH is going to be 9. Okay, so what that means is anything that is not a straight 1 is going to be somewhere between two numbers. So the way to do this is to take your number, 1.25 times 10 to the minus 2 molar, all right? Now, it's easy to say, well, of course, this is bigger than 1 times 10 to the minus 2 molar, right? Because, so you're just going to take the one that's below it. I would do that one first. That's the easy one. Now, the one that students get confused on is, all right, which one is bigger than this one? 1 times 10 to the minus 1 or 1 times 10 to the minus 3? Remember that with negative exponents, 1, I was just thinking 3. With negative exponents, the lower the exponent, the higher the number. So this is a pH of 2, this is a pH of 1. So this is between 1 and 2. Think of it this way. This is, remember, these numbers are placeholders. If the number is greater than 1, then we're basically going this way, right, with our decimal. But if the number is negative, we're going the opposite direction. So this is 0.01, and this is 0.1, and this number is bigger than that number, right? Let's do this one down here. All right, I'm not going to do this one. I'm going to let you do this one. Let's do this one right here, because this is the little tricky one, so I'll let you do that one. 10 to the minus 4 molar. All right, we know the easiest one is 1.0 times 10 to the minus 4. That's going to be definitely bigger, right, because it's just by the coefficient. But again, is it going to be 1 times 10 to the minus 5 or 1 times 10 to the minus 3? It's going to be 1.0 times 10 to the minus 3. We're going to go down a number. This is 0.0001 and this is 0.001. So this is greater, so if this is a pH of 4, this is a pH of 3, then my range is between 3 to 4. Okay, so that's how you're going to make those approximations. Now, the reason I bring that up is because you're going to be doing this again here. Now, this one was kind of hard for people, so I'm going to kind of go through and kind of show you what it is they want. You've got these Kas, and you should be able very quickly to say which is the stronger acid and which is the weakest acid. So the way they have this is they want, given the range of the following, convert them to pKa or pKa without a calculator. I want you to do that. And then rank them, assuming they are all 0.1 and give or accepts 1 proton. So here are my Kas. Now, what that means is that has got to be my strongest acid. So that is going to be 1. And then we go 2, 3, 4, and 5 for the other strengths, right? Because the higher the Ka, the stronger the acid. Now, how am I going to rate pH? Well, pH is the negative of the log of this. Now it says a high pH should be ranked 5 and a low pH should be ranked 1. And that corresponds with my acid strengths, doesn't it? Because the lower the pH, the stronger the acid. So this is going to have my lowest pH. I'll let you work out the rest. Now, for these, or well, let me just say this. This will have my highest hydrogen ion concentration, which is my lowest pH. All right. Now, here's my range. You're going to do the same thing with these. You're going to find out, for instance, where 1.2 times 10 to the minus 4 lies. Whatever this number is will be your low value. Whatever this number is will be your high pK value. Now watch out over here, because these are pKb's. The higher the base concentration, the higher the OH concentration, or the lower the H ion concentration. Be careful with that here when you do this one. Okay, so I just wanted to give you a little bit of heads up about those problems.